Okay, if you just follow my example, trying to find, excuse me, looking for the curvature of a vector curve, or a vector function, it was a little bit detailed there, and actually the function we worked with was not a bad or very difficult function, but all the steps to it was really quite involved. So finding the curvature based on this definition, it may not work, and I suppose you could argue that it would always work. Um, it may be very difficult to calculate. So there is an alternative form that may be much more convenient to use at times. And actually, I'm going to offer this without proof. I'm sure our text has a proof of it, or you can find it online if you want to take a look at the text, or the proof of it. Kappa, our curvature, that's supposed to be kappa, sorry. I'm going to write this as a function of t. Can be written as the magnitude of r prime of t cross r double prime of t divided by r prime of t, the magnitude of this guy, cubed. Now, right away, I'm thinking that's got to be easier. There's no way that's more difficult. So let's go ahead and work through this with the same vector function that I worked out using the definition earlier. First, just find some individual components here. I need r prime of t. This is going to be the vector 1, t, 2t. I also need r double prime. That's going to be 0, 1, 2. So, I'm going to need the magnitude of r prime, because I need to cube it. So the magnitude of r prime of t equals 1 squared plus t squared plus 4t squared to the 1/2. That's the magnitude cubed. So this is going to be 1 plus 5t squared to the 3/2. That's what's going to end up in my denominator here. So let's just go ahead and find this cross product now. R prime of t, there we go, that's a t, kind of, cross, oops, r double prime of t, I'm not going to worry about the magnitude, I'll do that later, is going to be equal to, I'm going to use a determinant for this guy, see, I, j, and k. R prime is 1, t, 2t, 0, 1, 2. So now if I work out this determinant, I'm going to have 2t minus 2t I minus, see, j is going to be 1 times 2, which is 2. 0 times 2t, that's minus 0, so that's just going to be 2j. Plus, k is going to be 1 times 1, which is just 1, minus 0. So this is just going to be plus k. Now notice this is 0. So what I'm going to end up with is this magnitude is going to be 0, negative 2, and k, that's 1. So let's see, there's my vector. So I need the magnitude of this thing now. The magnitude of r prime of t cross r double prime of t equals the square root of negative 2 squared plus 1 squared, which is root 5. So now my curvature is going to be this guy. See, kappa as a function of t is going to be root 5 divided by the denominator, which we said was going to be this guy, 1 plus 5t squared to the 3/2. Now compare that with the answer that we did when we did it using the definition, and I think you're going to see it's the exact same thing. A little bit more direct. It's a little bit quicker to get to.